All right, good morning, guys. Um, Today's going to be a little bit longer video for you, but we have some things we need to cover. The whole purpose of this unit is to get you to be able to read a weather map and be able to make a forecast from it. And over the next few days, a lot of your assignments are going to be based on you're going to get a weather map, and then you're going to practice interpreting what's going to happen. So I need to be able to tell you right now what the symbols on the weather map are going to be. And we're going to go through this and take a look at this because there's really, when you do a weather forecast, there's really four things you need to know to make a decent or adequate weather forecast. You need to know what the temperature is going to be. Is it going to be warm out or is it going to be cold out? You need to know if it's going to be cloudy or sunny. You need to know if there's going to be wind. And you need to know whether it's going to rain, snow, or not. And if you can determine those four things, you can make a fairly accurate weather forecast for what's going on out there. Now, all of this is based on air masses and how air fights each other and battles. You have to think of weather as a tug of war or a pushing contest. It's like a offensive line and defensive line in football. They're pushing on each other back and forth. And the strongest one, or the one with the most force, wins. And that's going to determine our weather. That's usually based on one of the biggest components is air pressure. Air pressure is going to determine whether we have sun in the sky, whether it's cloudy. Air pressure is going to determine some of our precipitation patterns, whether we have rain, snow, or a nice day outside. And so we're going to talk about air pressure first. We're going to talk about the high and low air pressure systems. Then we're going to talk about the cold air and warm air and how they fight each other. So when these components, pressure has high and low, that's two, and temperature has a cold front, warm front, that's two. When those four things get mixed together, they actually predict what our weather is going to be like at any given time. So the goal here then is I'm going to cover this today, and unfortunately the only way to do it is for you to see the information here. There's no hands-on, go out and do an activity. You're just going to have to listen to me. So I apologize ahead of time for that one, but hey, this is what it is. So here we go. So the first thing we're going to talk about is air pressure. Now, this is our start, and here's the key. That a high pressure system results in fair weather, happy weather. I like to think as high pressure with an H equals happy weather. And that a low pressure system results in bad weather. And I think low pressure is an L for really lousy weather. And so that's how you keep it straight. When you see a weather map with an H's and L's on it, and I'll quickly flip you over so you can see one. For instance, like this, you can see the H's and L's. Well, where there's an H, that's happy weather. Where there's an L, that's lousy weather. And you can even see on the map where the H's are, there's no clouds, no rain, no snow, no precipitation. But where the L's are, you start seeing clouds and rain and things like that. Now, the other lines on there, that the blue line is a cold front, the red line is a warm front, and that tells us temperature. And we'll talk a little bit more about this. I want to get through this display first. So, as we talk about this, air pressure. Air pressure is based on the density of air. So I want you to think about this. Warm air rises. We know this. You guys talked about this when we did our energy unit. Warm air goes up. Now, as warm air goes up, it's because it's less dense. If you think about it, and remember, warm air, if you're hot, you kind of want to expand out. And air does the same thing. It expands out, which makes it less dense. And if it's less dense, it's going to go up. Cold air, on the other hand, when you're cold, you pack in real tight and you get, shivering. And that means you're making yourself denser. And if you're dense, you're going to sink. So now we have warm air going up, cold air coming down. As this happens, warm air rises, cool air sinks. As this happens, we want to know that it can vary on Earth at any given time. Wow, I had a slide drop out. So as this happens, as warm air rises, warm air will go up, and I can draw this real quick. As warm air goes up, it starts to rise. Well, as it goes up, that air begins to cool. So as air begins to cool, it starts to shrink back down a little bit. When that happens, the water in the air, we call that humidity, the water in the air can't stay in there anymore because the air particles are starting to squeeze it out. And what we see form is clouds. So as warm air goes up, this is warm, as it goes up, it starts to cool. As it starts to cool, we see clouds starting to form. And as those clouds starting to form, eventually rain comes out. Now, if I'm taking the air and I'm lifting it up off your shoulders because warm air rises, this is a low pressure. On the other side of this, if we have air that's up here and it's cold air is dense, it's coming down. As it comes down, it starts to warm, which means it can soak up, it's soaking up water. As it soaks up the water, that means there's no water that's going to come out of it. So the clouds disappear. And we have a sunny, nice day. Well, this is how pressure works, the air pressure. So as air pressure goes up, oh, by the way, because this is coming down, it's pushing down on your shoulders, this is a high pressure system. So when cold air sinks, we have high pressure. When warm air goes up, we have low pressure. And this gives us a convection current, which means it cycles from high pressure to low pressure, to high pressure to low pressure. So this is how our weather is determined by air pressure. And it changes all over the world. I mean, it's constantly in motion. It's constantly changing. So this is the pressure pieces, all right? And we'll talk a little bit more. We'll get to it if it doesn't make sense. Just remember, low pressure is lousy weather. High pressure is happy weather. Happy weather, no clouds. Low pressure, lousy weather. Clouds form and you get rain. All right, so the next one. Fronts. Now, the fronts are those blue and red lines that you see on the map. And what you should be able to do is describe what's going to happen when you have a cold front, what's going to happen when we have a warm front. So there are really two types of air masses here, guys. There's cold air and there's warm air. And these air masses don't mix. That's why we have a front. It's like two people running into each other. One's going to win, one's not going to win. So there really are two different air masses, and we break them down into four categories. A cold front. A cold front is where cold air is winning. It's pushing the warm air backwards. You have a warm front. That's where the warm air is winning and pushing the cold air backwards. You have an occluded front, which is they're kind of pulling apart from each other. And then you have a stationary front where you have two people, cold air and warm air, are pushing and they're not moving. The net balance or the net force is zero. These are the four types of air masses that you're going to see on the map. Generally speaking, we don't do a lot with the occluded front. We usually focus on cold front, warm front, and stationary fronts. The occluded front is kind of the exceptions to the rule type thing. So we have our air masses. You can see air mass 1. The thing you need to know is that warm air comes from the south normally. So if they say, hey, you have a south wind today, it usually means the temperatures are going to warm up. Cold air usually comes from the north, the poles where it's cold, and it usually goes from the north to the south. So if you have a north wind, you're going to say the temperatures are going to cool off. That's generally what happens here. All right, so how do air masses move? Well, cold air goes down, warm air goes up, And when they run into each other, the cold air is kind of lifting the warm air up out of the way and sliding it off. It'd be like a really, really low to the ground car going underneath a pickup truck. It's going to kind of pick that back end up and shove the truck out of the way. And it is a battleground. That's the one word that you'll hear a lot of times in weather, is that this is a battleground between the two masses. And it's a shoving contest. It's like two sumo wrestlers out pushing on each other. Whoever's stronger is going to win. So one air mass is always pushing the other out of the way because they do not want to mix. And this is where we get our storms from. All right, so a cold front. What happens at a cold front? Well, in a cold front, you have warm air being shoved out of the way by cold air. And so a fast-moving cold air mass runs into a warm air mass, and the warm air gets thrown up. The forecast, heavy rains, thunderstorms. And it's easier if I get this out of the way and I show you what's going to happen. So we have our ground. We have a cold air mass right here. And it's moving this way. Well, what it's going to do as it moves this way, the warm air is going to go up the side of the cold air. Now remember, as warm air goes up, it starts to cool and form clouds. If it keeps going up, it'll form more clouds and big clouds and clouds that look like big thunderstorm clouds. And this cloud right here is what we call the cumulonimbus. It is the anvil head thunderstorm cloud. The clouds will start going up, and then eventually rain and bad stuff start falling down. So when the cold air bumps into the warm air, it's going to lift it up, causing that warm air to cool as it goes up. As it cools, clouds form. When the clouds form, eventually it cools enough that the water will come out and it starts to rain and storm here. This is the setup where you have bad storms. The thunderstorms form in this model. This is where we get the possible tornadoes. This is where we get the severe thunderstorm warnings. This is where the bad stuff happens. If it happens in the wintertime, this is where you get your blizzards and heavy snowfalls. So it depends on the temp. But a cold front generally means that you're going to see some heavy rains and storms. All right? The symbol for a cold front. On the map, you're going to see a blue line with triangles on it. And these points indicate which way the air is moving. So when you look at it on a map, you can see if we were to use this as our map, the cold air is moving up right now. All right, a warm front. Well, what happens in a warm front? This is where warm air is going to hit the cold air. Now again, the warm air is moving fast, but it's also lighter, which means when it hits the cold air, it's going to go up the back side of the cold air, up on top of it. When that happens, and you can see the cold air right here, there's your cold air. The warm air is going to go up the ramp, and as it goes up, it's going to slowly cool. Where in the cold front, it goes up really, really fast, and it cools really quickly, and that causes bad storms. This one's going to go up very slowly up the backside, and clouds will form. And the forecast for a warm front is slow, steady rain. This is where you get your April showers and your light rain coming through. You get some flurries in the air in the wintertime, but you don't get the bad storms. This is the ones where you have your normal stuff taking place. So a warm front generally means a slow, steady rain. The symbol for a warm front, of course, is a red line, meaning warm, red for warm. Warm fronts generally mean that the direction of the bumps is the direction that the front is going. So in this case, again, the warm front is going up. All right. So looking at a weather map, if we look at the fronts, we can see on this map, and try white and see if that works. We can see on this map, right here is a high pressure system. Now, if you remember, in a high pressure system, there is no rain because the air is getting pushed down, which means there's no clouds, no rain. So right here, because of the H, we can make a forecast that it's going to be sunny and clear. No clouds forming. Easy forecast. Over here we have an L. Now remember, that's low pressure. That means air is starting to rise, clouds are starting to form, and you're going to get cloudy, rainy, dreary kind of days. Well, that's the forecast over here. It's going to be cloudy and possible rain, or snow right there. So now we've started our first weather forecast. Now we've got to deal with these lines, and I want to focus on this one right here. You can see that that's a cold front. That means there is cold air on this side, and there is warm air on this side. Now, why? Well, if the cold air, you can see the teeth, the cold air is moving this way. Which means if the cold air is moving this way, this has to be the cold, and it's winning, it's pushing down. This is the warm air, and it's losing. So now we can add to our forecast right here, sunny, clear, and cold. Over here, because it's on the warm side, this is cloudy, possible rain, and warm. And really, that's 90% of your forecast right there. If you know these symbols, you can generally predict what's going to happen. All right? I'm hoping you get this. All right. Now, stationary front. If we go back a slide, you can see that this is a blue, red, blue, red, blue, red, blue, red. That's what a stationary front is. A stationary front is when a cold air mass and a warm air mass meet, but nobody wins. They just sit there, and they push and push and push, but nobody is moving. When that happens, the weather forecast is going to be cloud, rain for multiple days on end until somebody wins. It'll just sit there and rain on you and rain on you and rain on you, or be cloudy and cloudy and cloudy. That's what a stationary front means. So if you go back and look at this map, this area right here is a stationary front, which means it's not moving. And where those two air masses meet, it's going to be cloudy and rainy until this moves. Over here, we know we've got a cold front going into a warm front. And if you remember, that means cold going to warm, thunderstorms on this line. But over here, nobody's winning, so we don't get thunderstorms. We just get constant rain, constant precipitation over time. And that's a stationary front. Weather forecast, clouds, rain for multiple days. The symbol, of course, is the interchanging line where you see red, blue, red, blue, red, blue, and it's not moving in any direction. All right, review. Cold front. Cold front means thunderstorms, severe storms, blizzards, heavy rains, bad stuff. Warm front, gentle flurries, summer rain showers, the nice rainstorms. Stationary front means just a cloudy, dreary, nasty day for days on end. It's going to rain for 4 or 5 days in a row. An occluded front, not going to worry about. All right, so let's take a look at a couple maps. And we will talk about, let's do this one first. This one might be easier. As we look at the map, we want to look for the highs and lows. So right here is another high. Right there is a high. That means
sunny, or the better word is clear, and calm weather. Clear, calm weather. Over here we have a low. That means the lousy weather. That means it's going to be cloudy and windy. And you can see all over the map that we have a cloudy, windy, cloudy, windy, cloudy, windy, clear and nice, cloudy, windy, all over the map. So you can look at one of these maps, say for Iowa, Des Moines, right here. Right now we know that Des Moines, on this map anyway, that Des Moines has sunny, clear, calm weather. But eventually it's going to get cloudy and windy, then it's going to get clear and calm, then right afterwards it's going to get cloudy and windy again. And I should mention, all weather in the United States travels from California to New York. It always goes from the west side of the United States to the east side. So this stuff will not hit Iowa. It already has. It's past us. This stuff is what's coming at us. And so when you make a weather forecast, you'll be looking at what is to the west of wherever your city is. All right. So now we're going to look at the cold front, warm front. Here's our first cold front right here. We can see from the arrows that it's moving this way. All right. And on this line, because it's a cold front, we have thunderstorms. Or if it's wintertime, you're going to have blizzards. So from this line, you're going to see that the cold air is winning. So if we were talking about right here, you would say, hey, today it's warm. Tomorrow we're going to have thunderstorms, and then it's going to get cold. But it'll be sunny and clear when it's cold. So there's our cold front. Here is a warm front, and it's moving this way. So we know from our weather forecast that, hey, it's sunny and clear in Des Moines today. Tomorrow we're going to have, it's a warm front. We're going to have gentle showers, because that's what a warm front means, gentle showers. We're going to have gentle showers or flurries, depending on the temp. But it's going to get, because of the low here, cloudy and windy right along with it. You see how a forecast starts to form. And we can look at all these maps. Right here is a stationary front, which means it's going to rain for multiple days on end. Lousy weather, happy weather. We can go through and we can look at all these maps, and you can start making a forecast. Here's that map back again. So the forecast for the United States. Let's see, the northeast. This area right here is all sunny and clear. Notice the cold front. So it's sunny, clear, and cold. Down here in Florida, Mississippi, Georgia, Louisiana, you're going to have thunderstorms. And through Oklahoma, Colorado, Utah, Nevada, we're going to have rain for multiple days. And for this area down here, it is cloudy and windy. That's how you're going to do your weather forecast. All right. Again, we have that same map that we had earlier. I don't know why I put it up twice, but I guess I did. We don't need to worry about that. So what I want you to do, you will need to pause your video on this screen. There are 12 questions here. I would like you to use the video that you just saw. I will share the jam with you as well. So you should be able to look this up on the jam. Just pull up this slide. You should be able to answer these 12 questions. This is your assignment for Thursday and Friday. Watch the video, answer all these questions, turn them into me on a Google Doc that is attached to this assignment. Hope you guys have a great couple days. If you have any questions, as always, make sure you email me. We will be practicing reading weather maps for the next few days. So that's what you can expect in your assignments, is some weather maps, and then I'll be asking you to fill out what the weather is going to do. Have a great weekend, guys. We'll see you on Monday.